At its current constant speed, a train travels 50 kilometers in 10 minutes. And let t equal time in minutes and d equal distance in kilometers. Part 1, well, actually, I encourage you to pause the video and try to do all of these parts, and then let's do it together. So part 1 says write a formula for distance in terms of time. So generally speaking, we can think of distance is equal to rate times time. And we can figure out the rate because they tell us the speed. At its current constant speed, it can travel 50 kilometers every 10 minutes. So one way to think about it is the rate is going to be equal to 50 kilometers every 10 minutes. And that's the same thing as, if we just say 50 divided by 10, that's 5 kilometers per minute. So that's our rate. And so if we want the distance in terms of time, it's just going to be 5 kilometers per minute times our time. So 5t. Next, write a formula for time in terms of distance. There's a couple of ways we could approach this. The way I would do it is just start with the equation we wrote in part 1 and solve for t. So if d is equal to 5t, if we divide both sides by 5, and why am I doing that? Well, then if I have 5t and I divide it by 5, I'm just going to be left with a t on the right. But if I do it to the right side, I have to do it to the left side as well. So I'm going to get t is equal to d over 5. T is equal to d over 5. And all I did is I took this top one and I divided both sides by 5. If two things are equal to each other, as long as I do the same thing to both, then the next statement I get will be true. Part 3, complete the table to show the relationship. So the first one, this first row over here, they give us distance but not time. So it'd be useful to use this second equation or formula or whatever we want to call it, because this solves for time when we're given the distance. So we know that time is equal to distance divided by 5. Our distance is 10, so if we divide that by 5, we are going to get 2 minutes. And all I did is apply this. I just said t in this situation is going to be equal to our distance, 10 divided by 5. All right, the next one. We're given time, we want distance. Well, here I would use this first equation, or this first formula, where we know that distance is equal to 5 times the time. In this case, 5 times 4, it's going to be equal to 20 kilometers. And then last but not least, they give us the distance again, want us to figure out the time. Well, we already know how to solve for time in terms of distance. T is equal to distance, 35, divided by 5. I'm just applying this, which is equal to 7 minutes. So now they want us to plot these 3 points and draw a straight line through them. So actually, I'm going to use some colors here. That's always fun. So this first one, time 2 minutes, distance 10 kilometers. Time 2 minutes, distance 10 kilometers. That's that point right over there. This next one, time is 4 minutes, distance is 20 kilometers. 4 minutes, 20 kilometers. That point right over there. And then last but not least, we have time at 7 and distance at 35. Time 7 minutes, distance at 35. And now I just need to connect those points. Okay, so I can make one end go through one of these points, right like that. And you could use a ruler if you wanted, or maybe even the side of a notebook. It might look something like that. And I just have to connect the points. There we have it. I have done all of what people ask. And it's always good to do a reality check to just make sure it makes sense. At 0 time, we've gone 0 distance. And then every minute, notice, I've gone 5 kilometers. Every minute, if you take the number of minutes and you multiply by 5, you figure out how far you've gone. Every extra minute, I go 5 more kilometers. Every extra minute, I go 5 more kilometers. And it's a constant speed, so it makes sense that that trend just keeps going throughout this line.